Hello, welcome to another lesson of Algebra 2. This lesson is Quadratics 2.3, Graph to Symbolic. Today we will be learning how to determine a quadratic function in symbolic form given its graph. And then we will also learn how to determine the vertex of a quadratic function in factored form. In the previous section, we learned how to graph quadratic functions that is given in equations or it's given in a factored form. In this section, we will learn how to reverse the process to build our own symbolic representations of the form f of x. Let me put an underline on this one. F of x equals a times x minus r times x minus s from the graph. So we're super familiar with how this one looks, where we have an a value. Sometimes the a value is a negative, or we even have ones that are fractions, right? So the a value can be anything except that it cannot be a 0. And then we have x plus 5 or x plus 3. So those are the things we called factored form in a symbolic form. Okay? How do we do it? The first thing you do is you have to determine the zeros of the quadratic function and use them to find the factors x minus r and x minus s. And then you locate a third point on the graph. When you say third point, it could be because you already have your x-intercepts, and that's already 2 points. When you say third point in the graph, that cannot be your x-intercepts, right? It could be anywhere in the graph, but sometimes it's useful to use the y-intercept. So when we say third point, it could be the y-intercept, it could be the vertex, or it could be something else that's part of the graph. Yeah? It doesn't have to be the y-intercept at all times. It could be any point in the graph that you will find useful. And then in number 3, the third step is you have to plug in x and y values of the third point into the partial solution, and you simplify the resulting equation, and you have to solve for a. And then the last step is that you write the complete solution in symbolic form. Okay, let's have an example. Find the symbolic representation of the following quadratic function, and then find the exact coordinates of the intercepts in vertex. So let's take a look at our graph over here on the right. We have, I think we have the y-intercept already, really good. 0, 4. We have our x-intercept at 2, 0. We have another one at 4, 0. And then we have our vertex. Let's put the vertex like there. And then we have a vertex. What is that? Is that a 3 as the x is 3? But I don't know the y of the vertex. So that might be a little bit difficult to just like, okay, this is negative something, right? Negative 0 point something, but we do not know that at this point. It could be negative 1, I don't know that. But in order for me to know that, I need to have my equation. I need to have, we call it the formula, right? Or the symbolic representation of this graph, okay? According to the graph, the zeros of the quadratic equations are at 2 and a 4. You see this one? 2 and 4. And these are called the zeros. In other words, those are the x-coordinate of the x-intercepts. Okay? Corresponding factors of the quadratic function are x minus 2 and x minus 4. Now, how did it become x minus 2 and x minus 4 when it's positive 2 and a positive 4? Remember when we were doing it before, like if let's say for example, your factors are x minus 2 and x minus 4, right? And then if you make these equal to 0, you would get x is equal to 2 and x is equal to 4, correct? And so if your x's of the x coordinate of the x-intercepts are positive 2 and a positive 4, before that, they were a negative 2 inside it, right? Before it became positive 4, inside in a factored form, that was an x minus 4. Okay, and I hope that is making sense. And if you notice, let me just go back quickly over here. You see how we have f of x equals a times x minus r and x minus 6? Right now, I have the x minus r and the x minus s, but I do not have this a value. So I'm going to write what we call a partial solution. And when I say partial solution would look like you already have the x-intercepts there. You have the factors already, but you do not know the a value. So how do we get the a value? Let's go to the next slide. Find the symbolic representation for the following quadratic function, and then find the exact coordinates of the intercepts in the vertex. So now we already found our x-intercepts, right? And then I have here, it says, and then find the third point. So this is my first point, my second point. My third point would be either the y-intercept or the vertex. But looking at the vertex right now, it's not a whole number. So it's 3 comma something that I do not know. And because the vertex is, I would call it unreliable at this point, I'm not going to use the vertex as my third point. I'm going to use the y-intercept as the third point. Okay, and then the coordinates of the y-intercept is 0, comma 4, right? 0 as the x and 4 as the y. Okay, and then we're going to have to, remember that we have to find the a value. In order for us to find the a value, we would need a value for the y. So you know how we had our equation, we have, hold on. Remember we had our equation as f of x equals a x minus 2 and x minus 4. Yeah, and because we're solving for this value, we would need a value for the x and the value of f of x. So technically, we need a y value and we need an x value. And because we're using the third point, which is the y-intercept, the x of the y-intercept is 0. So you see the one that we plug in over here on the x. I'm going to plug in 0 in there, and I'm going to plug in 0 in here. And then for the y, I'm going to use the number 4. So instead of the whole f of x, the f of x would be gone for now. And then I'm going to change that into a 4. Okay? Let me clean up a little bit over here. And that's the reason you have a 4 in here. Or I could put, let's put that over there. F of x equals a x minus 2 and x minus 1. There you go. I hope that's better. And so the f of x became a 4 because that's the y of my third point. And then I plug in 0 because that's the x of my third point. And then I'll just solve this one. 0 minus 2 is negative 2. 0 minus 4 is negative 4. And then negative 4 times negative 4 is positive 8. And of course, I will divide 8 on both sides. Because I want to isolate a, yeah, I want to leave a alone. So I'm going to get rid of the positive 8. And so dividing by 8 will give you a 1/2. Therefore, let's go back there. Therefore, our equation is going to be f of x. Our final symbolic representation. F of x, instead of a, I'm no longer going to write a because I know that the a value is 1/2. X minus 2 and x minus 4. Okay? And remember, we were told to get all the intercepts in the vertex. So I already have my x-intercepts. That's already given in the graph. I already have my y-intercept. That's already given in the graph. But, I mean, I do have my vertex too, but I do not know the y of my vertex. It looks like just under 0, but what specific number would that be? So, in this case, I would have to get the vertex. And I think you guys are familiar with how to get the vertex already. The x of the vertex you can look in the graph. The x of the vertex looks like, let's go back to the graph. Okay, I think we can really tell that the x of the vertex is 3, right? because the x of the vertex can be found in between or halfway between your two zeros. So then the middle of 2 and 4 would be positive 3. But I don't know the y of the vertex, so what I'm going to do is plug in the 3 into the equation, plug in the 3 into the equation, and I will get negative 1 half. Okay, because 3 minus 2 is 1, 3 minus 4 is negative 1. 1 half times 1 is 1 half. 1 half times negative 1 is negative 1 half. And here are all the answers that I have. I have my symbolic representation, or you can call it your equation, you can call it the formula of the graph. And then we have the x-intercepts here, we have the y-intercept here, and then we have the vertex. So this right here is already given in the graph, so that wasn't so bad. This one was given on the graph, that wasn't so bad either. And then the 3 was given in the graph, but we just have to solve for the negative 1 half. Yeah? Okay, let's try another one. Let's try another one. Find the symbolic representation for the quadratic function f of x. You have to state the coordinates of all intercepts in the vertex. Okay? Let us start with getting my f of x. So, getting my f of x would be a, remember, that's a and then x plus or x minus. At this point, I do not know. Because I'm not looking at the graph yet. I'm just like, putting the things I know in advance. Okay, I know that this is something comma 0, something comma 0. Y-intercept, I know that 0 comma something. And then the vertex, I do not know, but I know that the x of the vertex would be x1 plus x2 divided by 2. At this point, again, because I'm pretending not looking at the graph, I still do not know. Okay? Let's go to the graph. We have, what do we have? What is this one? Is that a negative 6 over here? So we have 0 comma negative 6 for our y-intercept. Okay, not bad, right? Not bad. That's like, whoa, that was it? That was so easy. Okay, moving on. Let's take a look at this one. What is that one? Is that a negative 1? That's a negative 1 comma 0. And then what is that? Negative 1, negative 2. This is negative 3 comma 0. Oh, look at that. We're almost done. Okay, and then let's get the x. This is the vertex over here. Let's get that there. The x of the vertex would be 1, 2. Oh, sorry. The x of the vertex is negative 2, and then the y of the vertex is positive 2. Hey, look at that. I almost filled everything in. Okay, so I have my x-intercept, I have my y, and I have my vertex. But everything is given. This is so cool. And I do not have this one though. Okay, let's fill that in. Because this one is a negative 1, before it became negative 1, when it was inside the parentheses, the factored form would that be x plus 1, right? And then the negative 3, the factored form for that was x plus 3. That makes sense? But now, I have to get that a value over there. So let me write that on the corner. I have f of x equals ax plus 1 and x plus 3. And according to the step-by-step solution earlier, you need to find the third point, okay? So this is my first point, that's my second point, and I can use this or this to get the third point. And it's up to you if you want to do the vertex, but I do personally like the y-intercept because you know how you just plug in zeros, it doesn't really do anything. So I'm gonna use my y-intercept. So I'm gonna plug in 0 comma negative 6. So because my x is 0, I'll put the 0 in here. And then for the y, I'm going to put negative 6. Yeah, because f of x is the y, right? The y. Okay, let's move on. Negative 6, that's positive 1, positive 3, that is 3. And then we need to leave a alone. We need to isolate a. So I divide by 3 on both sides. And what is that? Negative 2 equals a. And then you see this a right here. That's only a placeholder. And now that we know that the a is negative 2, I can delete that. I'm going to put negative 2. And you are done. You have everything that you need and everything that is required for you to get. And I didn't even need this formula, yeah, because my vertex is pretty easy and it's just a whole number and I know that this is a negative 2 and a positive 2. That wasn't really that was not that hard, yeah? Okay, let's have another example. Example number 2. Find the symbolic representation for the quadratic function. State the coordinates of all intercepts in the vertex. Okay, let's see. Remember that before I look at the graph, before I even try to see what the graph looks like, I already have things written, right? So this is, green. Let's take that out. So we have A, X, I don't know yet, X, I don't know yet. Then my x-intercepts is something comma 0, something comma 0. My y-intercept is 0 comma something. And then for now, I don't know any of the vertex, but I know my vertex is x1 plus x2 divided by 2. Okay? Let's see. I have my, there you are. I have my x-intercept here, my 0. That is at negative 1 comma 0. Let me put negative 1 comma 0. That's for the x on here. And then I'll have 1, 2, 3. That's 3 comma 0. And then I have my y-intercept. What is that? 1, 2, 3. That's negative 3. Correct? That's a negative 3. And then my vertex is, I know it's a 1. And, it's perfect. 1 comma negative 4. Yeah, so I don't really have to solve for the vertex here. This is so cool. Okay, then I just needed my a value, and before I can even solve the a, I have to fill this in. Because our zeros are at negative 1, before it was a negative 1, when it was a factored form, that was an x plus 1, yeah? Because then you do x plus 1 equals 0, x is at negative 1, right? And then this positive 3 here, that was an x minus 3 because x minus 3 equals 0, x is equal to positive 3. So technically, it's just the reverse, yeah? If it's a positive in here, it's a negative in there. It's a negative in here, it's a positive in there, and the other way around. Okay, let us solve for our a value. We have, how do we solve that again? We do partial solution, and then we look for, what do we look for? We look for the third point. So I have these, I have my x-intercept, those are my first point, 2 points, right? And my third point could either be the y-intercept or the vertex. But my favorite is the y-intercept. I always use the y-intercept if it's given. So I'm gonna do my y-intercept. So plug in, do I plug in? 0 comma negative 3. And so 0 is the so 0 is the x value. And then for the value in the f of x, I'll plug in negative 3. So we have negative 3 equals 1 and negative 3. negative 3, that's another negative 3. We divide negative 3 on both sides. Let me erase this one right here. If we divide negative 3 on both sides, we'll get a positive 1, right? So A is equal to positive 1. Then I will go all the way here. Because my A is positive 1, that means I don't have to write anything in there. Right? So it's just an x plus 1 and x minus 3. Or you can write a 1 in there, but that doesn't really mean anything. Like, there's already a 1 in there, even if we don't show it. Okay? So that's done. Number 2. Number 3. Find the symbolic representation of the quadratic function with zeros at x equals 1 and x equals negative 3, which goes through the point 7, comma, negative 20. State the coordinates of all intercepts in the vertex. Okay, here we have a big problem. We do not have the y-intercept. We do not have the vertex because the graph is not there. Right? All we have given is just the x, just the zeros, just the x coordinate of the x-intercept. But still, we can do that, right? So we have x, we don't know, something, comma, 0, something, comma, 0, 0, comma, something. And then I don't know the vertex yet, but I know that the vertex is x, the first x plus the second x divided by 2. Okay, let's plug in stuff. So if my x's are 1, so I have a 1, comma, 0, negative 3, comma, 0. Okay, that's kind of like done deal already. And then x plus, because of the positive 1, in factored form, that's a negative 1, x minus 1, because then again, x minus 1 equals 0 will give you a 1. And this negative 3 was a positive 3 in the factored form. Okay, now what? We're going to get our y-intercept, but we can't get the y-intercept because we do not have our equation, our symbolic representation. And that is then the next step that we have to do. We have to get the value of A so we can solve for every single thing that is missing in this lesson. In this example. Okay, what do we plug in? Plug in. Usually, if you know how in number 1 and number 2, I always use the y-intercept, but in here there's no y-intercept, but we're given a value of a third point. And the value of the third point is 7, comma, negative 20, where the 7 is the x, and then the y is negative 20. What I would do is, I will put negative 20 because that's where the y is. Let's change that into a blue. And then I'm going to plug in 7 minus 1, 7 plus 3. Okay, I hope this is not that confusing. 7 minus 1 is 6. That's a 10. 6 times 10 is 60. And then I need to leave A alone, so I'm going to divide 60 on both sides. And what's negative 20 divided by 60? That's a negative 1/3. Correct? Yeah, because there's 3 20s in the 60. So we have a negative 1/3. So I'm going to erase this A value over here. And I'm going to put negative 1/3 in it. There you go. And so because we have our final symbolic representation, I can then solve for my y-intercept and my vertex. Let me clear this up over here. And let us solve for our y-intercept. How do we solve for y-intercept? Do you guys remember? All we have to do to solve for the y-intercept is plug in 0, right? So we have plug in 0, we make x 0. So we have 0 plus 3. Oh, I still have negative 1/3. Okay? We have negative 1/3, negative 1, and positive 3. Negative 1/3 times negative 1 times positive 3 will give you 1. Right? Okay? And so we have our y-intercept is at 0, comma 1. Okay, what else are we missing? We have the x-intercepts, we have the y-intercept. Oh, we don't have our vertex yet. Okay? Let's get our vertex. How do we get our x of the vertex again? We divide the two zeros, the two x's of the x-intercepts and divide them by 2. So all I have to do is get those numbers. I have a negative 3 plus 1. Divide that by 2. Hopefully that is making sense. That's negative 2 divided by 2 is negative 1. So the x of the vertex is negative 1. But I still do not have, let me make this up a little bit. But I still don't have the y of the vertex. And in order for me to get that, I will have to plug in negative 1 on these two things right here. So I have f of negative 1 equals negative 1/3, negative 1 minus 1, negative 1 plus 3. So we have negative 1/3, that's a negative 2, that's a positive 2, right? So we have 2 times 2 is 4, divide by 3. So I have 4 over 3 for my vertex, or you can say 1 and 1/3, it doesn't really matter. So that's how it's done. Sometimes in number 1 and number 2, everything is given, right? But in number 3, which could be on your quiz, number 3 is like the graph is not there, so we have to figure out every single thing that is missing. Okay, the next page is a homework, but I'm going to model how to do number 1 and number 2, and then you can do numbers 3 and 4 on your own. Okay? So we have our x-intercept, so we have f of x equals negative 2, x plus 3, and x minus 1. Okay, do you guys remember how to do this one? First, we have our zeros. We have our x-intercept, x plus 3. That's negative 3. So I have negative 3, comma 0. Then x minus 1 equals 0. That is x equals to 1. We have 1, comma 0. And then remember, I usually, right after I get stuff, I put them in the graph. That way I don't forget where they belong. And these are the x-intercepts, so they belong along the x-axis. Okay, let's get the y-intercept. Remember, y-intercept, plug in, 0. We have 0 plus 3, 0 minus 1. That's a 3, right? And that's a negative 1. That's a positive 6. So we have 0, comma, positive 6. And then lastly, we'll get our vertex. You guys remember, to get the x of the vertex, that is adding the two x's. So we have negative 3 plus 1 divided by 2. Negative 2, that is a negative 1. Or you can like just really look at the 2 points in here. What's the number between positive 1 and a negative 3? So cross out, and the middle is a negative 1. Yeah? Okay? And then, how do we get the y of the vertex? To get the y of the vertex, we will do... Oh, I know that the x of the vertex is negative 1, and I just need the y. I will go back to my equation. We have, I'm going to plug in negative 1 in there. Negative 1, hold on. Okay, negative 1 plus 3, negative 1 minus 1. negative 2, positive 2, negative 2. And that altogether is a positive 8, right? And so negative 1 and positive 8. We have 0, comma 6 for my y-intercept. Oh, you know what? I should have put that in purple. That way we don't get confused. Like, oh, why is that blue? Is that the vertex? Nope. That is my y-intercept in blue. Ah, come on. It didn't change the color. Okay, there you go. And then in blue is my vertex. It's at negative 1. What is that one? Negative 1, positive 8, all the way on the top over here. Okay, so we have a graph facing down. There you go. And you are done. You have all the given points already here, and then you have your graph. Okay, let's do number 2. Find the symbolic representation of the following quadratic function. State the coordinates of the intercepts and the vertex. So let's start. We have, remember, when we do this, we do a x something, something, comma 0, something, comma 0, 0, comma, I do not know, and both of these I do not know. But I do know that the x of the vertex is adding the two x's and dividing them by 2. And based on the graph, let's plug in stuff. My first x here on the left is a negative 3, comma 0, followed by another one on there on the side, 1, comma 0. We have my y-intercept at a 0, comma negative 2. I have my vertex right here, really easy, negative 1, but I do not know my y. Okay? And I think from here, I am going to let you go and do it on your own. Your homework is this one, number 3, and number 4. Okay? I started the solution for you, and then hopefully by watching the video, you'll be able to complete it on your own. Thank you guys. I'll see you on the next video.